So we're shooting an electron through a solenoid, and we're trying to figure out how many revolutions it would make during the travel time if it's shot at a bit of an angle. So here is the axial length of the solenoid, and the electron's going to be shot at a little bit of an angle at about 31 degrees, and then from there it's going to start making rotations because inside there's going to be a magnetic field, and so it's going to make little rotations off of that. So something like that. Now the idea is that let's try to figure out how many revolutions it would take during the travel time. If we want to try to figure out the travel time, well, let's think about it. It's going to spend a certain amount of time in here. So time spent in the solenoid. And if we divide that by the time it takes to make one rotation, rotation time, then we should be able to get the number of rotations, because we'll have the entire time, and then we'll figure out how many times it's split up into all the little bits, and then we'll get that total number of rotations. So the time spent in the solenoid is going to be like t equals the length divided by the velocity of, well, in the x direction. It would be going this direction because there's two, there would be one in the y direction. And if we want to try to figure out the x direction of this, and this is the 31 degrees, well, it should be v cosine theta. If we're in the x direction, this would be the sine theta component. Okay, so that's technically what we'd be putting over into that component. So we can start by saying this will be L divided by what we know is the velocity, so 8/13, and there's also a cosine of 31 in there. So this is going to be the top part of our equation. Now the second part is going to be the rotation time. And we should be able to figure that out based off of our t equation from the circular motion of this stuff should be this little period equation, 2 pi m over qb. All right, now from here we kind of already know the mass, so we got 2 pi times the mass of an electron is 9.11 e to negative 31, and we kind of already know the charge, that would be 1.6 e to negative 19, and then we're left with a b. We know that that b for the solenoid is supposed to be b sol is mu naught, and then we have an I, and then there's that N over L, and then that should be right. If we try to figure this out, we already know mu naught, and we know the I, so let's go ahead and try 4 pi e to negative 7, and then we have 3.9, and then that would be the number of turns, 80/90 over L. Oh, really close. So let's plug in this rotation time into here, so that way we can get the number of rotations. Let's plug in the rotation time. That would be the big T. Over here would be 2 pi 9.11 e to negative 31. And then over here we could say 1.6 negative 19 there. And then we'll plug in the b. That's going to be 4 pi e to negative 7, 3.9. And then there's also 80/90 over L. Now I can rearrange this equation by putting that stuff on top. So I can kind of say that L over 813 cosine 31 times 1.6 e to negative 19, 4 pi e to negative 7, 3.9, 80/90 over L. Divide that all by the 2 pi 9.11 e to negative 31. And at this point I should be able to plug this into the calculator, because look, the L and the L will cancel, top and the bottom right there. You can kind of put this on the denominator if you wanted. And so that would be the 1.619, and then we'll do times 4 e to negative 7 times the pi also got 813 cosine 31 times 2 pi times 9 negative 31. Bam. So we get, you know, like 1.6 e to the 6th rotations. It's quite a bit, but yeah, that's basically the answer. Kind of crazy.